Righto, Year 11, Year 12, here we are with the first video for our next topic, DS5, that's normal distributions. So what we're going to begin with is sampling techniques here, right? Ways that we can generate a good sample. Now, a reminder, a good sample is representative. It doesn't contain bias. Okay, it's representative, it doesn't contain bias. Right, good sample. We can make samples better, maybe by being bigger, but that can be hard work. So other good ways of getting a good sample is to make it random. Sometimes a systematic sample and sometimes a stratified sample. Okay, so a random sample is we need to assign some sort of number, perhaps some sort of code to each item in the population, and then we choose some of those using some robustly random technique. Right. Maybe using a spreadsheet with a random function or your calculator or a list of random numbers or something like this. Okay. We choose those. Good for a homogeneous sample, okay, where everything in that population has pretty sort of similar attributes. It's not grouped together. Systematic sample is where we choose the first item at random and then a regular interval afterwards. Okay, so this might be, let's say I ask every 10th student who walks through the gate in the morning. Right. Now this is good where you have a population of unknown size, something that's maybe continually growing. Right, students going through the gate, or cars driving past, or something like that. Perhaps the police might be doing RBT, random breath testing. They might use a systematic sample. They might say, well, we're going to pull over every 10th car, right, and test them, right? Because they don't know how many cars there's going to be. They can't just pull everybody over and then go, okay, you, and you. That's not how it works. So they use a systematic sample, perhaps. Finally, a stratified sample, where I have a population with groups, like well-defined groups, let's say maybe male and female students or people from different towns or different age groups or something like this. Then I want to get the same proportion in my sample from each group as I have in the population. Right? That seems fairly sensible. A percentage is a nice way to work on it. It doesn't have to be done as a percentage, but it can be a good way to understand what's going on. Anyway, let's see how this works. Example 1 here. What sort of sample would I use for this here? Well, Year 12 students, we haven't sort of defined them as belonging to any other particular groups. They're all in Year 12, I think, in which case, right, that's a well-defined group that I could find out how many people there are. I could assign some sort of random number to them, and that would mean that I think a random sample is probably the best way to do that one. Now, the quality of service in a major retail store. This is one of those things where I've got an undefined population size, perhaps. So I think this is good for systematic, where I'm going to grab every 20th person or something that comes out. Right, so that sample is growing all the time. And the type of books to buy for the school library. Well, it sort of depends on who I'm asking there, but let's say that we might talk to people from different faculties. Maybe we're talking to teachers from different faculties, or perhaps we want to represent the proportion of people who take different subjects, right? So if there's a lot more maths students, then maybe we buy more maths books, right? Proportionally, something like that. Or if it's maybe a 7 to 12 school or something, well, maybe then we use a stratified sample for the different age groups, right? So if there's more Year 7s, they get a bigger say in what books we get. Okay, so that might be a good example of where to use a stratified sample, perhaps. Now, we can use random numbers here. Sometimes your calculator might do some of these things. Now, the calculator that I have on the screen here, this doesn't do it. This calculator, if you follow here, will generate a random 3-digit or a random number, 3 decimal places between 0 and 1. So you can see this random here, second function random, and if I choose option 0 there, I can go equals. Right, it's going to give me those. Now I could say I'm going to use the first or the last or the middle digit or something if I want just a number between 1 and 10, or I could take the first 2 digits or something to get a 2-digit number, something like that. Right, so I can get, random numbers there. I can't, there you go, small one. I can't force it to do anything other than those 3 decimal places. Some other calculators, you can sort of do a rand between kind of thing. I can say I want numbers between 1 and 10 or 1 and 15 or something. That can be handy sometimes. Not on this one here. This one does do like a roll of a dice, right? I can get random numbers between 1 and 6. Right? If I do that function there again, if I do 1, right, that's going to give me random numbers between 1 and 6 as though I were rolling a dice. How exciting. Okay. Or we can use this table here. You just choose a spot at random, right? Let's go here. Oh, in fact, you know, the example here uses, I think, this one here, right? Let's just start there at random. And I want 2-digit numbers, so let's go 60, 57, 29, 92, 36, 25, something like that, right? Those numbers are arranged in some random order. So wherever I start, I get some random numbers. Not fabulous. To be honest, I don't think using a table like that is a real fabulous way of doing things, certainly not for a large set, because there are patterns in the sense that if you keep using the same table, well, you kind of get the same patterns perhaps, eventually. So, that's using random numbers. Now, quickly here, we've got this thing here. What I want to do is I want to choose a random sample of 15 students from here, from this list. Right, so out of this 86, now I can't use this, but you know what I'm going to do? Hang on a moment, I'll show you something. If you have a look here, I've got a spreadsheet. I love spreadsheets. And I've typed in this rand between. Okay, that's going to generate a random number between 1 and 86. Righto. Now I can potentially repeat this 15 times. Right, I can repeat that 15 times. That does have the potential to choose the same person twice. Right, so I don't know. There could be 262s there. I don't know. There's no 6. So that's not brilliant, but most of your random things are going to do that anyway. You'd have to be pretty careful. In which case, exclude them. Choose another one at random. Right, just sort of run that process again. If I do something like, let's have a look. Formulas. Calculation. Calculate now. Right, I can just keep re-randomizing those, get a different sample of 15 numbers there, right? So, come back here, and right, whatever those 15 numbers are, I choose their names off, and they're my students. Right, very exciting. Finally, example 3. Now, this is a bit more challenging and interesting, and my screen won't scroll. 5 students. Oh, sorry. Yeah, family has 5 students, or 5 children here, right, these ages. I'm going to choose 3 of those. I want to choose 3 of them. How many different samples of 3 can I choose from there? If you think about it, it's going to be a combination, not a permutation, right? Because the order that I choose them in isn't important, but the combinations. Now, I want combinations of 3 from a group of 5, right? We can use a formula that's 5 factorial over 3 factorial times 2 factorial, right? 5 minus 3. I can do that, or I can use the NCR button on my calculator. I don't know what's happening with my screen here. Let's see if this one works. I can. Right, so I have from 5, I want to choose 3. There are 10 ways that I can do that. Okay, now, what is happening to my touch screen here? Oh, look, this. Okay, who are they? Well, I can have 1, 4, 12, 1, 4, 10, 1, 4, 6. 1, 6, 12, 1, 6, 10, 1, 10, 12. Right, that must be all of them. Must be all of them. Was that 10? Must be. Anyway, this isn't right anymore. That's going to be the end of the video. Okay, hope it was great.